Question number 10. Refer to the tick mark diagrams and graph when needed. Imagine a bug that is moving twice as fast as the ladybug. On each tick mark diagram, mark the position of this bug. Okay, let's imagine a bug twice as fast as the ladybug. How about a green bug? When time equals 0 seconds, the green bug is also here at the starting point. When time equals 2 seconds, the green bug has gone twice as far as ladybug. Ladybug has gone 4 centimeters. So 4 times 2 equals 8 centimeters for the green bug. Let's count out 8 centimeters. 1, 2, 3, 4, 5, 6, 7, 8. Here's the green bug's position, twice as fast as ladybug. I'll label that 8 centimeters. At the time equal to 4 seconds, ladybug has traveled 1, 2, 3, 4, 5, 6, 7, 8 centimeters. So green bug has traveled 8 times 2, 16 centimeters. Let's label that. 8, 9, 10, 11, 12, 13, 14, 15, 16 is right here. I'll mark that, 16 centimeters. At time equal to 6 seconds, ladybug has traveled 8, 9, 10, 11, 12 centimeters. So how far has green bug traveled? Well, remember, green bug is twice as fast as ladybug. So 12 centimeters times 2 equals 24 centimeters. Let's label that on here. This was 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Here is green bug's position at 6 seconds. You need to mark the position on this graph. You don't have this drawing tool like me. You'll need to use GeoGebra tools. How about putting a point where you want it? So there it is, green bug at time equals to 0, and green bug's position is, let's go ahead and just type it in here. Green bug is at 0 centimeters at 0 seconds. Okay, type that in. Now at 2 seconds, green bug is at 8 centimeters. Put a point on there and then please type it in. At 2 seconds, green bug has traveled 8 centimeters. Type that in, label your point. And then at 4 seconds, green bug has traveled 16. Put a dot there on the tick diagram and go ahead and label that 16 centimeters. Please be descriptive in your labels. I said green bug, but this time I'm just going to put 16. I'd like it if you label at least some of them describing what you're labeling, like green bug has traveled. At 6 seconds, green bug has traveled 24 centimeters. Let me label that. At time equals 6 seconds. Green bug has traveled 24 centimeters. Okay, there we go. Now you did it. You've labeled the graph for a bug that is moving twice as fast as ladybug. Let's go down here. Question 11 says, plot this bug's positions on the coordinate axes with lines U and V and connect them with a line. So we need to plot these points on the coordinate axis. Oh no, my scale has disappeared. I put the scale in way up here, but now it has disappeared. I need to do it again. Do you remember what the scale was? The vertical axis is time in seconds. Each unit is 1 second. So here is 1 second, 2 seconds. Please label your scale again. 3 seconds, 4 seconds, 5 seconds, and 6 seconds. And the horizontal axis we had for centimeters. But now I know that green bug is going to travel 24 centimeters after 6 seconds. It goes off the graph. What should I do? Should I leave it going off the graph and only plot some of the points? Or should I change the scaling? I can change the scaling to whatever I need to change the scaling to. So let's go ahead and change the scaling and see what we get. The first tick mark will be 2 centimeters. Oh, wait a minute. I can't do that, can I? Let me see here. After 2 seconds, 2, 4, 6, 8. No, I can't do that because the lines are not adjusted. We have to use the same old scale. Just forget I said that. In the next unit, I'll show you how to change the scaling on your graph, but not this unit. Let's keep going with the same old scale we used previously. Each tick mark is 1 centimeter. 1 centimeter, 2 centimeters, 3 centimeters. Let me try to get my centimeters a little nicer here. 4 centimeters. I'm going to skip some, but keep counting correctly. 6 centimeters. I'll just do the even ones. 8 centimeters. 10 centimeters, 12 centimeters, 14 centimeters, 16 centimeters. That's not centered very well, is it? 18 centimeters. Here's 20 centimeters. And then our graph stops. Should I try to label things off the graph? Usually no. Usually we would change the scale so it fits on the graph. I'll show you how to do that in the next unit. Okay, now let's label these points. So for the bug that is twice as fast, I called him green bug. He starts off at 0 centimeters in 0 seconds. After 2 seconds, green bug has traveled 8 centimeters. Please label that. After 2 seconds, green bug has traveled 8 centimeters. There we go. After 4 seconds, green bug has traveled 16 centimeters. So that's here. 4 seconds is here. And after 6 seconds, green bug has traveled 24 centimeters, which is off our graph. But here is 6 seconds. And then 20, 21, 22. It's going to be like here. Now draw a line connecting these points. And this line should fit all of these if we drew it correctly. There. I can see that my 1 point, which is off the graph, is not drawn correctly because it should definitely be on this line. So I know that that point was not drawn correctly. And that makes sense because I couldn't see the lines anyway. Let's get rid of it. Okay, now look at this just a little more. Does it make sense? Look at what you have drawn. Does it make sense? If green bug is twice as fast as ladybug, then let's see here. I'm going to just change that. Okay, so here was ladybug. Oops, I'm using the wrong thing. That's not what I wanted. Not that. I want this one. Pencil. If ladybug had traveled 8 centimeters in 4 seconds, did I draw correctly? Yeah, green bug has traveled 8 centimeters in 2 seconds because she's twice as fast. Let's look at it from this direction. Ladybug, after 3 seconds, she has traveled 6 centimeters. So green bug should be at 12 centimeters. Yes, that makes sense. Twice as fast. So check what you have drawn and make sure it makes sense. This is green bug's line. I'm going to label ladybug's line because it's so fun to draw with color here. Ladybug's line. Oops, there we go. Oh man, my drawing tools do not work perfectly. There it is, that's better. And then ant's line is going to be in this desaturated red-gray color. Okay, question 12 says, write an equation for each of the 3 lines. Aha, now this is where we need to start using proportional relationships. Y equals kx. The k is a constant of proportionality. In this case, the k is going to equal the change in time divided by the change in distance. And I got that just by looking at the labels on my graph. The y-axis is elapsed time. The x-axis is distance. So the slope of these lines, that is the same as this constant of proportionality. This constant of proportionality is the slope of these lines. Do you remember slope from our last unit? Let me give you some reminders. If you don't remember, I'm going to refresh your memory. Hold on. Let me write this a little bit bigger. You need to take notes. Slope of a line equals the change in y, whatever the y value is, divided by change in x. Change in y divided by change in x. Now let me draw that on the graph so it makes a little more sense. Let's say I'm looking at Ladybug's line, and from starting position to 2 seconds, what is the change in y? From starting to 2 seconds, the change in y is 2 seconds. And then what is the change in x? The change in x is 4 centimeters. So make a ratio, 2 to 4. This is the slope of Ladybug's line. It says that for every 2 seconds, I'll put units here, for every 2 seconds, Ladybug travels 4 centimeters. Okay, that is the slope of Ladybug's line. We can use that to write an equation for Ladybug's line. Her line is that her y, the y value, equals 2/4, that's the constant of proportionality that we just calculated from the slope, 2/4 times the x value. Okay, now don't just take my word for it. Does this make sense? This means that for every value of x, her y goes up by half. So let's check that. When x equals 8, when x equals 8 here, what is the y value? So if x equals 8, 8 times 2/4, that means 8 times half, then the y equals 4. I'm going to make a little table here. You should take notes in your notebook to help you understand this. Make a table like this. So I just guessed 8. Okay, at 8 centimeters, then how many seconds has gone by? If I look at the graph, I see 4 seconds has gone by. And when I do the math with my equation of a line, it agrees 4 seconds have passed by. Let's try another number. Let's say that Ladybug travels for 10 centimeters. So x equals 10. 10 put in a 10 here for this x value. And then 10 times 2/4, let's go ahead and do the math here. 10 times 2/4, that equals 10 times 1/2, which equals 5. So does it take 5 seconds for Ladybug to travel 10 centimeters? Let's look and check. 10 centimeters takes, go over here, yes, 5 seconds. So this equation tells us where Ladybug will be after any amount of elapsed time we want. The y equals elapsed time, and the x equals Ladybug's distance. So if we know any distance, we can calculate how long it took Ladybug to get there. Let me go ahead and type in my answer for Ladybug's line. Okay, Ladybug's line is y equals, 2/4. I can reduce that to 1/2. 1/2 x. Okay, that's Ladybug's equation of her line. Now, you better take notes on paper. If you're just listening to me, you're probably not going to get this very well. So let's keep going, and let's now calculate the slope of Ant's line. Remember, the slope equals the change in y divided by the change in x. So for Ant, take a look at his line. Let's pick some points off of here. This point right here looks good. It looks like at 3 seconds, Ant has traveled 9 centimeters. You know what? That is a good point, but I'll do something even easier. At 6 seconds, 2 seconds, Ant has traveled 6 centimeters. So the change in y is 2 seconds. There's the change in y. And the change in x is 6 centimeters. I'm going from starting at 0, okay? So from 0, y has gone up 2 seconds. Let me put that here. 2 seconds up divided by 6 centimeters over. I like to use the units everywhere I can. Go ahead and put the units down while you're taking notes. 2 seconds over 6 centimeters. And let's reduce this fraction. That's going to be 1/3. That is the slope of Ant's line. In other words, the constant of proportionality for Ant is 1/3. Okay, come down here and write an equation for Ant's line. For Ant, y equals 1/3 times x. Now, does that make sense? Let's see if that even makes sense. I'm going to make a little table here, and I'm going to have some x values, and I'm going to have some y values. This is for Ant, so I'm using Ant's color. Let's say when x equals 10 centimeters, what is the y value for Ant? Well, according to my equation over here, it's going to be 1/3 of x. So y is going to be equal to 10 divided by 3. 10 divided by 3 is about 3.33333. Let's take a look at the graph. When x equals 10 centimeters, the y, which is seconds, does that equal about 3.333? Yes, it does. Let me use my line tool to help you see it. X equals 10 centimeters, and the y, which is time, is going to equal about 3.33, 1/3, about 1/3, 3 1/3. So that makes sense. Let's try another value. When x equals 16. Okay, x equals 16. So go down here to our equation. what is the y equal when x equals 16? We have y equals 1/3, that's a 3, times my x, which I said to be 16, then y equals 16 over 3. Can you reduce that fraction? 3 goes into 16 5 times with 1/3 left over. So let's see it. Let's see it on the graph. I'll use a line to help me visualize this. So x equals 16 is right here. Go up to Ant's line right there. And then see what it is on the y-axis. 5 and 1/3. Yes, that's about 5 and 1/3. Here's 1/3. Okay, so that makes sense. Make sure you check your numbers that they make sense. Oops, I deleted everything. So there's Ladybug and there's Ant. Now, using my same method, please tell me the equation for the green bug's line. Use my same method, and if you're confused or you didn't take notes, go back and take notes. The way to get this problem correct is to look back at your notes and answer correctly. So you have one more answer to put in here, and that is for green bug. What is the equation for green bug's line? It's going to be y equals some constant of proportionality, whatever that's going to be, times x. In this parentheses here is the constant of proportionality, k. And you need to solve for k by looking at the slope of green bug's line. That is k. Solve for green bug's k. Solve for that, okay? I have a number here and a number here, and you need to have a number here to get your credit for doing the assignment. Okay, thanks guys. See you later.